Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of PGP cryptographic keys under rings. So how the PGP services are implemented with the help of cryptographic keys along with the key rings. We will see in this class. So cryptographic keys under key rings. So the generation of the keys, that is session keys, public keys, private keys, all these keys are using for the encryption purpose or decryption purpose. So this all the encryption and decryption mechanisms are applied with the help of cryptographic functions. Cryptographic functions that all we discussed in the previous sessions. So cryptographic functions are used to do the process of compression, do the process of encryption, do the process of digital signature. So how that all the keys and the key rings are helpful to provide such a type of services. So here the PGP makes use of four types of keys. The services, PGP services, the PGP services which are already discussed in the previous sessions: authentication, encryption, digital signature, segmentation, compression, all these services, email compatibility, all these services are offered with the help of different cryptographic functions. But all that cryptographic functions, how the keys are generated, how the keys are implemented, how the keys are used for the encryption and decryption process and digital signature process. So how that all the keys and the key rings are used for the cryptographic process, we'll see in this session. So here the PGP makes use of four types of keys. PGP makes use of four types of keys. First one is one-time session symmetric keys. One-time session symmetric keys. The name itself is symmetric and asymmetric. Symmetric key and asymmetric key. It stands for the key which is used is the same at the moment of encryption and decryption process. So from the sender side and receiver side, they can use both keys as the same key, as a same session key for doing both encryption and decryption process. So then it is said that a symmetric key. Symmetric, the name itself, symmetric. Same key we are using for the both encryption and as well as decryption. So example, the public key which we are using for the encryption can be used for decryption also. But for encryption we are using public key, and for the decryption we are using private key is nothing but asymmetric key. So the process of applying the keys, session keys for the encryption and decryption process, if it is same, then it can say that is symmetric keys. If it is not same, then it is treated as asymmetric keys. It is treated as asymmetric keys. So how that all the keys are offered for cryptographic functions. So here the public keys and the private keys, along with that passphrase based symmetric keys. Passphrase based symmetric keys. These are all the four types of keys, cryptographic keys that are helpful in providing such a type of service called authentication, email compatibility, digital signature, along with that encryption decryption process. So three separate requirements can be identified with respect to these keys. So what are those requirements? What are the requirements that are helpful to use these all the keys? What are the requirements that are used to apply these keys? So the first one is what? A means of generating unpredictable session keys is needed. A means of generating unpredictable session key is needed. So they can understand that nobody can use the same key. Nobody can expect that the key is using for this encryption or decryption purpose. So that means generating unpredictable session keys is needed. Unpredictable session keys is needed. We would like to allow a user to have multiple public or private key pairs. Multiple public key or private key pairs. So the public key and private key pairs. So which generating for the data transmission with the help of both encryption and decryption. So for doing encryption, you can use public key, and for the doing decryption, you can use private key. So generating users has to allow the public and private key pairs to do that encryption and decryption process. To do that encryption and decryption process. As a result, there is not a one-to-one correspondence between users and their public keys. So the result is one-to-one correspondence between users and the public keys. Thus, some means of needed for identifying particular keys. Some means of needed for identifying particular keys. So which type of key is used for encryption, which type of key is used for decryption, and the type of session key is generated. Type of session key is generated. Each PGP entity, each PGP entity is nothing but each PGP service must maintain a file of its own public or private key pairs, as well as a file of public keys of correspondence. So it has to maintain the records of the recorded documentation or recorded file of maintaining the public and private key pairs, as well as how many ways we can use that public keys, how many ways we can use that public keys as a encryption process or encryption keys for the correspondence. So maintain that all the records, and means of generating public keys, means of generating private keys, maintaining that public and private key pairs, and wherever the session key is needed, automatically the keys will be generated. For all these types of requirements, we have to understand that the types of keys is cryptographic keys. Types of keys, cryptographic keys. So in the first one is what? Session key generation. Session key generation. So how the session key is generated? So each session key is associated with a single message. Each session key. Suppose the message have hi hello. So this is the message. For this message is treated as M. For this message, a session key is associated. A session key is associated and is used only for the purpose of encryption or decryption. So this is used for either encryption purpose or either decryption purpose. So the generation of session key is for the message, and it is being used for either encryption or decryption. So recall that message encryption or decryption is done with symmetric encryption algorithm. So here the symmetric key encryption algorithm generates session keys or symmetric keys. Session keys are symmetric keys. So symmetric keys that applies on both sides public key. That applies on both sides public key. For encryption purpose, it uses public key, and for decryption purpose, it uses public key. But for asymmetric encryption algorithm, it uses for encryption public key, and for using decryption private key. It uses private key for decryption. So public key for encryption, and it uses private key for decryption purpose. So that is the way of generating session keys. The input to the random number generator. The input to the random number generator consists of 128 bit key. This is a random number using keystroke input from the user. So your user has to enter the keys from the input, a key from a keyboard. It has to take 128 bit key, and it is applying as a random number generator. And two 64-bit blocks that are treated as a plain text to be encrypted. Using CFB mode, cipher feedback mode. Two 64-bit cipher text blocks are produced and concatenated to form the 128-bit session key. So that is nothing but 128-bit public key or private key. The algorithm that is used is based on one specified ANSI X12.17 ANSI X112.17. So that is the standard that algorithm uses to generate that all the keys. So message, for that message applying a session key, the session key is generated for both either encryption purpose or decryption purpose. But for encryption purpose it uses public key, and for the decryption process it uses public key in the symmetric algorithm, private key in the asymmetric algorithm. Public key in the symmetric algorithm, private key in the asymmetric algorithms. Next one, key identifiers. So which type of key is generated, which type of, what is the ID of that key while it is generated. So it is possible to have more than one public or private key per user. So each user maintains one public or private key pair, or else having multiple public or private key pairs, whatever it may be. It has to store as a record of file. So each one therefore needs an ID of some kind. The key ID is associated with each public key consists of at least significant 64 bits. So public key, if public key is generated, then it contains ID 1, ID 2, ID 3. Similarly, private key generated, then it contains ID 1, ID 2, like that. So it has to maintain a separate record of files. So that is nothing but that is the key ID of public key is what? KUA. So this is a user authenticated public key, and which is a KUA mod 264 bit. It is a KUA mod 264 bit, and this is a sufficient length that the probability of duplicate key ID is very small. So this is sufficient length that the probability of duplicate key IDs is very small. A key ID is also used for the PGP digital signature. As the sender may use one of a number of private keys. Sender may use one of a number of private keys to encrypt the message digest, and the recipient must know which one was used. Must know which one was used. With the key ID concept, understand a more detailed look at the format of transmitted message as shown in figure. So here each and every key is generated from the session key. For each and every generated key, either public key or either private key, it must maintain some user ID. Or key ID. So if it is public key, then PUK is the user ID of public key. Similarly, private key, then private receiver key. So receiver side use private key, and sender side use public key. And receiver side use private key. And here we can see the diagram of the general format of PGP message, how the key IDs are applied to the public keys or private keys. So here we can see the notations. The first one is what? Encryption with user B's public key. So there are two users actually, and one is user A, and the second one is user B. So here the encryption E with users B public key. So user B, and which indicates that key, so that EKUB as the ID of encryption with users B public key. Similarly, encryption with users private key. So encryption with user private key. So user private key represents user private key. So which is a key? The key represents K symbol, and the encryption and the receiver private key, so that RE indicates that. So here encryption is user's private key, and the encryption with the session key, that is E, Session indicates that yes, and the key EKS. So indicates that what? Encryption with the session key. Encryption with the session key. And then next zip compression function. Zip compression function. And the next one R64 radix 64 conversion function. Radix 64 conversion. So these are the notations that are indicates that ID of the generator keys. ID of the generator keys. So EKUB is the encryption with user B is public key. The B indicates that user B, and here U indicates that user, and K indicates that key, and E indicates that encryption. So this is the ID of encryption with user B's public key. And similarly here the user A having private key, so that private indicates that R, and key indicates that key, and E indicates that encryption. So here the encryption with the user's private key, encryption with the user's private key. And then next EKS, which indicates that session key, encryption with the session key. And the zip conversion function, zip compression function, and radix 64 conversion function. Radix 64 conversion function. So here these are all the notations, and we can see the part of PGP message. Here the part of PGP message, this particular part indicates that session key component. Session key component. So which indicates that what? Session key type of public key or private key. Session key, it's a type of public or private key. So here the key ID of recipient's public key. So that indicates that KUB, and the session key indicates that what? KS. So here EKUB indicates that encryption with the users B public key. Encryption with the users B public key. So that is nothing but this is all the public key part. And the second one, signature part. This is all encryption with the private purpose. Encryption with private purpose. It contains timestamp, and it contains key ID of sender's public key, key ID of sender's private key, sender's public key, and similarly leading 2 octets of message digest. So leading 2 octets of message digest. The next message digest. So it indicates that all encryption with the user's private key. Encryptions with the user's private key. So that indicates that indirectly it applies digital signature. It applies that digital signature. So before compression the digital signature has to apply, the next compression applies, the next encryption applies. So here the same thing will happen here. So the same thing will happen here. So encryption with the public private key, encryption with the private user's key. The next one here, the file name, it indicates that file name, and the timestamp, and what the message, what the data actually contains in that file. What the message or what the data actually contains in that message. So the first one page is message, the next applies signature, the next generate encryption or decryption process. So for this all these things has to apply the zip compression function. Then next applies session key, encryption with session key, and converted into the compatibility point of view, radix conversion function. Compatibility point of view, radix conversion function. It applies. So this is all the overview of general format of PGP message that contains users ID, user keys ID, public key ID, private key ID, what is the file name, what message actually contains, what process they are doing for compression purpose, what process they are applying for encryption process, and everything we have seen here in this diagram. And the key rings. So key rings are nothing but key IDs are critical to the operation of PGP. Key IDs are critical to the operation of PGP. That means directly and what time they have to assign or apply the particular public key ID or private key ID. So from the previous figure, it can be seen that two key IDs are included in any PGP message that provides both confidentiality and authentication. That provides both confidentiality and authentication. And these keys needs to be stored and organized in systematic way for efficient and effective use by all parties. So it is the process of a systematic way that has to be organized and stored. So all the key IDs has to be organized and all the key IDs has to be stored in systematic way. Systematic way. So the scheme used in PGP is to provide a pair of data structure each node. Provide a pair of data structure at each node. So public and private key, pair of data structure at each node. In that one to store the public or private key pairs owned by that node, and one to store the public keys of other users known at this node. So the one node stores that public or private key pairs owned by that node, and the other one to store public keys of others users known at this node. So that it indicates that what key rings are nothing but a data structures. Key rings are nothing but data structures. So which indicates that which points towards the current node and the second node. So here the key rings contains a pair of data structures at each node. So one node stores that what public or private key pairs owned by that node. So both public and private key pairs having this node. And the second one to store the public keys of other users known to this node. That means directly pointing to the next node of the user. So it has to maintain that what the public keys of other users at this node. So public keys of other users at this node. So these data structures are referred to respectively as the private keyring and public keyring. Because of storing that all the public and private keyrings in a keyring. So public and private key pairs in a keyring, we can say that these data structures are referred as both private keyring and public keyring. And we can view the ring as a table where each row represents one of the public or private key pairs owned by this user. So each row contains their public or private key pairs along with that current node, and the second node indicates that public keys are used by another node. So here the table represents that here the private keyring data structure. It indicates that what data structure, and public keyring data structure. So which indicates that all the IDs, all the message formats of the PGP and everything. So what it contains actually? So it contains the timestamp of the generated, what time it is generated, and what is the key ID of the generated key, and what is the type of key generated is the public key, and the encrypted private key, and a user ID. So which maintains this private keyring maintains as a data structure of all these fields. The private keyring maintains that all the data structures of all these fields. What are the fields contains? The timestamp is one field, key ID is one field, public key is one field, encrypted private key is one field, and the user ID is one field. So all these fields contains in the private keyring data structure. And the second one is what public keyring data structure. So in this, the timestamp indicates the time of the keys generated, and what is the key ID based on the type of public or private key. And the third one, if it is public, then it is owned by that one. And then next owner trust, the next user ID of the next node of key, the next key legitimacy, the next applying signature and a signature trust. So all these fields are having in the public keyring data structure. So all these fields are having the public keyring data structure. Public keyring data structure. So we said that what the keyring is nothing but it is a data structure. It is referred as data structure which maintains the public and private key pairs in the keyring. So it maintains what public and private key pairs in the keyring. So how the private keyring contains fields actually and the public keyring contains fields actually. So the private keyring contains what timestamp, key ID, public key, encrypted private key, then next user ID. Along with that, public keyring data structures contains what timestamp, key ID, public key, owner trust, user ID, key legitimacy, signature, and a signature trust. So these are all the fields indicates that what the fields that are pointed to the node in the keyring's data structure. Pointed to the node in the keyring data structure. So they are all applied for both maintaining public and private key pairs as a record of the file. Maintains as a key pairs of the record of file. And the timestamp. So in that indicates that timestamp is nothing but what the date and the time. The date and the time with this key was generated. The date and the time. What is the date of the key pair is generated? So the date and the time when this key pair was generated. When this key pair was generated. The next one, key ID. The least significant 64 bits. Least significant 64 bits of the public key for this entry. So which uses what public key? So the public key portion of the pair and the private key portion of the pair. And user ID typically users email address. So this timestamp, key ID, public key, private key, user ID, all these are all the fields. These are all the fields that contains in the keyrings. So the types of keyrings are what? One is private keyring, and the second one is what? Public keyring. One is private keyring and the second one is public keyring. So these private keyring and public keyring maintains all these fields like a timestamp, key ID, public key, private key, and a user ID. So the private keyring can be indexed by either a user ID or key ID or both, if possible, or both. However, for security of the value of the key is not stored in the keyring. For the security purpose, the value of the key is not stored in the keyring. It stores key ID, it stores type of key, but not the value of the key. What value actually contains in the key. But an encrypted version of it, which requires a passphrase to decrypt, is having. But it doesn't have value of the key, but it contains what encrypted version of it, the key which requires for the passphrase to decrypt purpose. So without having the key value, we cannot able to decrypt, but which contains encrypted version of it which requires to decrypt. It contains. So as with all passphrase schemes, the security of this method depends on the strength of the passphrase. So how the version has to be encrypted without having the value, how it having the encryption version is containing the passphrase version. So that is all about that timestamp, a public key and a private key pairs of that this is public key and a private keys of that contains. So this is all about PGP cryptographic keys and rings. So once again we revise the topics what we discussed in this session. So here the first one is what PGP cryptographic keys and key rings. So there are certain types of keys one-time session keys, one-time symmetric keys, public keys, private keys, and passphrase based symmetric keys. So symmetric keys are nothing but what the keys which we are using for encryption and decryption purpose. We are using both same key. We are using both same key. So that is done by the session key generation. That is done by session key generation. So the type of key is generated from both encryption purpose and decryption purpose using the same key, then it is said to be symmetric key. But for the encryption purpose using say, public key and for the decryption purpose using private key, then we can say that it is asymmetric key. Asymmetric key. The session key generation is only for the generation of the public and the private keys. Generation of the public key and the private keys. So key identifiers. So key identifiers. What generated public and private key contains actually. They are maintaining some IDs of that keys. So public key ID and the public key identifies that P, the key which is used by the user as a public. So PUK, and the next key which is used by the person as a private, that is PRK. So private key. Encryption with public key, encryption with the private key. And here the message format, what fields actually contains in that message. So session key component, signature, message, and notations, how we can call it as encryption with users key public key, encryption with the users private key, encryption with the session key, a compression function, and radix conversion function. So all these contains in the files format. And key rings. So key rings are the key points, and it is represented as a data structures which maintains both public and private key records. It maintains both public and private key records in the form of nodes. So each node indicates that what it indicates that storing for public and private key pairs and storing for the public key of other users at this node. So they are maintaining as a data structures for implementing these cryptographic keys. So private key ring contains the values like timestamp, key IDs, public key, encrypted, private key, and user ID. And similarly, public key ring contains what the fields: timestamp, key ID, public key, owner trust, user ID, key legitimacy, signature trust. So these are all the general structure of public and the private key rings. So this is all about the PGP cryptographic keys and rings. So how the cryptographic keys are used to generate the security emails, generating the encryption key and decryption keys for writing security emails. So this is all about the cryptographic keys and rings. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.